welcome to this edition of the Killen Report. We've got a very, very exciting show, and we're going to be talking about the strongest climate change solutions. And in order to do that, let me introduce myself. I'm Jonathan Kleid, principal of Kleid Design Group, fine custom cabinetry in Oakland, California. And it is my great pleasure to welcome my guest for the entire show. He's a leading scientist, Ripudaman Malhotra. He has been associated for many, many years previously with the Stanford Research Institute. He is president of Malhotra Energy Consultancy, and he is the co-author of this wonderful book, A Cubic Mile of Oil. And for those of you who are regulars, in watching the Killen Report, you'll recognize him. It is a pleasure, Ripu, to have you here. Welcome.
Thank you, Jonathan.
It's a pleasure.
Always a pleasure to come.
Thank you so much. You know, I know that we're going to discuss solutions to climate change issues, but what we might want to do is just take a little step back to see how we got there, maybe discuss, I don't know, 3 or 4 of the real, what you would consider most meaningful, disastrous part of climate change and the impact.
Right.
Yes.
No, I think it's a good idea to do that.
So how would you, can you, just tell us from your point of view what those 3 or 4 impacts might be that are so detrimental?
Yeah. So there are many impacts, first of all, as you probably recognize. It could be storms, there could be water inundations, there could be displacement of people, there could be, many, numerous things. And if I think about it, kind of laid sequentially, it all begins with the warming of the earth. Now, that begins with the rapid increase, unprecedentedly fast, rapid increase in the greenhouse gas emissions in the atmosphere, that we have gone up from greenhouse gas CO2 levels being about 280 ppm before the industrial, and within 150 years or so shot up to 400 plus ppm. Never seen CO2 levels rise like this ever before. This is a greenhouse gas, which means it's like throwing an extra blanket on you. Mm-hmm. It keeps the heat in, the earth warms. Doesn't warm a whole lot, just a small amount, 1 or 1.5 degrees. But when it is a global average, it has tremendous impacts. Mm-hmm. And those impacts, if I could kind of cluster them up, one would be from the water levels. The ice melting and the sea, the oceans, because of the warming, expanding a little bit. So all the effects of water.
And what are we noticing with regard to sea life that's happening?
I'll talk about sea life in a second, because first thing I'm going to talk about is the water level rising. Remember, about half the world's population lives within 50 miles of coastlines everywhere. It's an enormously large, I may be off my numbers a little bit, but it's a surprisingly large number. Mm-hmm. So many people, billions of people, are going to get affected by the sea level risings. Now, not that every time if there's a 1 or 2 foot rise in the sea level, it's not going to inundate completely, but there are some areas will be, like in Bangladesh and coastal India, in Florida, in Louisiana. Things are going to get, they're very low, and there are no cliffs or things like that, so water is going to come in. Mm-hmm. And large parts of major cities. New York City is a prime example, some of the major ones in this country, all on the coastal properties, and that's going to be a major impact. Mm-hmm. Mm-hmm. The second category would be from the air. As the air gets warmer, it holds more moisture in it, and so the storms and how they are affected. So it's the weirding of the weather that happens along with it. You get many more storms, more intense storms. We never heard of falls with 30 inches of rain at a time. Now single storm systems bring that much. Mm-hmm. So many, and frequently. Not once in 300 years or something like that, but right. We hear it already often enough. Just a few years ago, there was the Harvey over Houston.
Right. Well, it's sort of hard, I suppose, to get what you're really saying. It's hard to have a once in 500-year event every year.
Every other year.
That's kind of a difficult
That's right.
thing. Yeah.
It's supposed to be every 500
Right,
years. And
right.
now we are having it frequently enough.
Correct.
So things have weirded. I saw one real example of this weirding of the weather. Last week I was in Chicago, and we had this big cold storm come in, but it came all of a sudden. There was snow on the ground, and that's nothing new in Chicago, but to see trees that still have leaves, and the leaves that are still green and just turning a little bit brown with absolutely snow white fields all around. That was a bizarre sight.
So let me ask you a question. Let me just interrupt just for a moment. There are many people who would say, well, if you go back to the Bronze Age or the Ice Age, we had weather stuff going on through all of these ages.
Yeah.
So in the midst of trying to perhaps deny that it's as a result of what's going on now, that it's just something that occurs with every great age over thousands and thousands and thousands of years.
Correct. That's the last phrase is very operative. Those changes have been very, very slow. Those ice ages, the melting and all that, they take centuries, many centuries. And the variations, but the CO2 levels have been up. They haven't been that. We've never seen 400 ppm of CO2. We have to go back way, way, way back, millions of years to see those kinds of things. We haven't seen those before. And the climate, the Earth was a completely different place at that time. But yes, the changes that happen because of the tilt of the sun or the tilt of Earth's axis, or, there are volcanic eruptions that but those are all relatively small compared to what we have done over here. It's all of a sudden, in a short, within the last 30 years, we have pumped as much CO2 as we have entire history. So this rise has been very, if you look at the graph for that, it is a step function. It is just
spike up.
Spike up.
Yeah.
Just a spike up, with no letdown, no way of seeing a way how it's coming down.
Got it.
And it takes a while. And this is a good point actually to bring up to the third effect that you're talking. The reason, in some ways, our climate, the change, the effects have been somewhat moderated because between a third and a half of all the CO2 that we put up was absorbed by the oceans. But that comes at a cost also. Because the ocean water, or the surface waters to begin with, become more acidic. And that affects the sea life question that you were talking about. It begins with the zooplankton, and begins with the mollusks, and begins with those little critters that's at the bottom of the food chain. If they can't make their shells, if they cannot make their things, and they cannot survive, and the slightly bigger critters cannot survive on them. The krill cannot, and then the fish cannot, and so on and so forth. And we get about 30–40% of our protein from the ocean food. Ocean is the source of that. So it's going to affect, I would see it as the third big impact. So we had the water inundation from the melting of the ice and expansion as the water gets warm. And water gets warm, then the weirding of the weather, so storms and all that, those effects. And the third is this. And what is going to really happen is that we're going to see people being displaced at levels unprecedented. We didn't have 7 billion people last time those climate changes occurred. So we're going to see hundreds of millions of people being made refugees in and having to look for other places. The weather means the food where we were growing, they may be growing things differently. We may start getting wine from Scandinavia instead of California. Things like that may happen.
That's interesting. Wine and Volvos. Yes,
Well, that was actually last week or week before a newspaper article. Some people were prospecting places in Scandinavia for putting in vineyards.
Right. So would you say this would be sort of your holy trinity of the problem of really these are the basic three
things,
problems of this situation?
Three problems, three major things, and they are all connected. Then they have other
Subcategories.
Subcategories and ramifications will be plenty.
So I hear, at least in public discourse, it's not too late, it's too late, it's not too late, it's too late. Where are we here?
Where are we? Well, if we are late. There's no denying that. If the best time was to start was 30 years ago, the second best time is to start today. I say that often. I may have said it on this show before also.
I think you might have, but let me ask you this now that you've made me depressed, and I wasn't before I started talking to you. Get me out of this depression. What is there that can be done? We've identified through you three issues that really have huge impact, and maybe the major three.
Right.
So can we counter that with maybe three others that might be a solution to what you've brought up?
Yeah. So again, I could take three categories kind of things.
Okay. Sure.
Yeah, like that. So as I said, it all started with having to put up CO2 in the air, so much of it, or so many greenhouse gases. Let's talk about it as greenhouse gases and not just CO2, because CO2 is the principal one, but there are others also, and some other very, very important. So how do we cut back greenhouse gas emissions? So cutting back greenhouse, that's the mitigation side of it. What can we do? Now, we don't put out CO2 because we like to. It's not because of the fun. It's because we need the energy, and the only source of energy that the world has right now in any substantial amount is burning fossil fuels. And that's what adds. And so if you're going to address that, we have to get to energy sources, commensurate scale, which do not emit CO2. And nuclear energy is the way to get there. Now, I understand people will complain that it's unsafe or that we don't have enough, and there are lots of arguments about it. But I think, or it's too expensive. They are all addressable. They're all addressable, and I think we have to. This is the solution. The other ways, just looking at wind and solar or the rapid rise of those, it just doesn't add up fast enough.
Right, there's just not enough of it to make the impact.
So
let's go back to the nuclear thing. So what's the premise of, besides, but there's Chernobyl, there's 3 Mile Island, there's those kind of things that really, I understand that. That is a psychological thing.
Yes.
What would you say to somebody who's fearful of nuclear in a reassuring way that it is safe, understanding that we have had, at Fukushima is another one, that we've had these issues in the past that they themselves are, as you would say, impactful for populations?
Yes. So the fear is real. But I think if you look at it in perspective, like per unit of energy that nuclear has provided and how many deaths has it caused, you'll say it pales. I mean, everything else causes many, many more fatalities.
So let me try to use another analogy. If we were talking about airline flight, and that how many millions and millions and millions of people, but then because there may be an unfortunate incident that has devastating effects for that particular plane, what you're saying is to lump that one incident or an incident under the whole guise of the entire industry.
It's not.
When you do numbers, just hard numbers. Obviously, if you were one of those numbers, that would be a very.
You're not a statistic.
You probably would not have as good a feeling about it. But in general, that's kind of what you're saying.
That's kind of what I'm saying. So, terawatt hour is a large amount of electricity.
How large?
Trillion kilowatt hours.
It's a lot.
Trillion watt hours. So 1 billion kilowatt hours. Okay.
That'll light up for a while.
For a while. So for every billion kilowatt hours that coal-fired power plant produces, on average, it causes about 160 or so fatalities. either from mining, either from the pollution effects, things like that. You know, people getting respiratory ailments and all kinds of things. So that's there. If we look at the nuclear, it's about 0.013. It's very, very limited amount. And I'm including in this an estimated 4,000 fatalities from Chernobyl, which according to the latest UN World Health Organization kind of estimates, they say, it's so small, I don't think we can even detect it. It's been 30 years. And there were some initially that we saw, 50 or so, that you can include, certainly, you would. And of course, it's a design that nobody uses, nobody cared, and that was I really recommend people to go ahead and watch the HBO series, plug for them, that Chernobyl series. But if you do that, please watch all 5 episodes, because if you watch the first 4, you probably come up with a very scary scenario. The narrative that they're building up is very different until you get to the 5th one, then you realize, as bad as it was, catastrophic as it was, the net effect wasn't so bad.
So what about people that are proponents of, let's say, lithium battery cars?
Yeah.
Or those kinds of devices that...
well, we will need those. We will need those devices because...
Can they be produced in numbers that really have a real effect?
So the energy source is not the battery. You know, the battery has to be charged. The battery doesn't come. So where's that energy coming from?
Right.
I'll need a nuclear power plant for it. But if I'm going to be using lithium-powered batteries for driven cars, I do need millions and millions of cars. Currently, we don't have the lithium supply. I was looking at, take a modest car like Nissan Leaf. It takes 40 kilowatt hour kind of a battery pack that it has, the newer ones. I don't think we can, the current supply of lithium that there is barely enough for 5 million cars.
Really?
That's all.
Wow.
So we need to really scale up, and these things take time. It's not, I'm not saying that there isn't enough lithium in the world. There is. Oceans are filled with lithium also, but it's expensive. Lithium can be extracted from many sources. We're going after the easy source, which are these dried up lakes in Chile and Peru, and that area in South America. That's the current. But there are other materials that we need. We need them, and we'll have to scale up. So the energy part was the one.
So nuclear is the first one.
And
in your opinion, the second one would be?
Well, I would say wherever you can, you may want to use the wind or so, things like that, the renewables. If there are cases where you could use that for the energy supply. Okay. Another big category would be an economic kind of thing to spur innovation and all that. You got to put a tax or a cost of carbon.
And what does that do?
So that makes the current fossil sources a little more expensive. And so it provides the businesses opportunities to start innovating and trying to find alternate solutions, gives them a little push up. And if you can make it in a way such that it is revenue neutral, that the tax or either through cap and trade or just, I would prefer a straight tax. I know politicians cannot. It's a political suicide very often. But if you can take the tax and then reinvest it, a good part of it back into this, or either give it to people or invest it into technologies for incentivizing the innovation
and research and
development. Because there is, even in nuclear power, there are so many innovations coming up. We have thousands of, the spent nuclear fuel. That's a resource that's sitting over there. We treat it as waste. It is not waste. It is 90% of the fuel value is still sitting in those things. A newer generation of nuclear power plants can use them up. All the weapons, we can use up all that as a fuel in the newer generation of reactors. And they need to be developed. They need to be deployed. It takes some R&D, and then RD&D is needed before you can scale them up.
What typically is happening with that waste, with the 90% that really is still available? They just
It is just
discard it, or what do they do with it?
It is being stored in dry concrete casks.
And that's it?
That's it.
So we have all this stuff that is just
Sitting there.
How close do you think we are to the technology that will allow us to use?
Oh, I think we're very close. If we start building them, we could. We built some of these in the 60s at Oak Ridge and then also in Idaho National Energy, where we demonstrated some of these technologies. And now I know there are companies who are trying to develop it, but I know it's very difficult to do anything like that in the U.S.
Right.
Well,
there's political will. There's all kinds of things that go into it.
All kinds of things that go with it. So that's a.
So we've got nuclear. We've got tax, the economic. So we've got 2 out of the 3 from your point. What would be the third
strategy has to be more about the mitigations. We really have to start thinking about how we're going to mitigate the effects because climate change is happening already. So how do we build some resiliency in our systems? What do we do to get our infrastructures out of the harm's way? What do we do to put are there some places may benefit from better sea walls, but others, it may not be the solution everywhere. But you got to really start thinking about, and that's again, $1 trillion worth of, it's investment. It's not a trivial amount. It's a huge amount, and we better start paying attention to that. That would be, but I think above it all, these 3 things, education has got to be the one. We have to educate the public not only about the severity of the climate effects that's happening, the fact that it is happening, and propose solutions that are commensurate with the gravity of the situation. Because I think many times we say people are denying climate change. It's not really a denial on their part, but the denial comes from the fact that the solutions being proposed are so Mickey Mouse compared to what the real challenge is. So this isn't going to cut it. So if I don't have a solution, I say, give it up.
So in your experience, what do you feel, because you've got your energy consultancy, what is the way that you find most effective to educate people about this? Talking with them, obviously, one-on-one maybe.
One-on-one is, or thank you, for example, you and Michael and others who helped put this message out. And the talking is you have to meet the people. You have to meet the people, really. And that's also, and sometimes acknowledge the fact that, yes, the fear is real. Yes, but show them the facts. And I think we have been misled so many times that people have kind of lost.
Briefly talk to me about we've misled. What does that mean?
I'm talking, okay, let's talk about nuclear. We have been taught as it's such a fearful thing. And so that has been ingrained. And I think that was a misunderstanding, and it started off out of abundance of caution, because we were doing the atmospheric nuclear tests, and we started saying that, oh, any radiation is bad. Okay? But that message stuck, whereas the fact that we are bathed in radiation from all kinds of sources, from cosmic and from ground up and from radon and
television,
from bananas. So there was this is an interesting episode. I don't know how much time we have, but I'll tell you this. 60 Minutes did a little show about tourists that are going to Chernobyl. And the people in the bus, as they're taking them, are asking, well, how much, they're being given dosimeters, you can clip on and you'll see. And they're saying, well, how much will I get? He says, well, as long as you don't kind of go off the track, or stay within. It's like standing next to 40 bananas for an hour. Okay, that's the level, and we make such a fuss about it, like it is the most deadly thing, But radiation, we grew up with radiation. Life evolved with radiation.
Sure,
and we have repair mechanisms in our body.
And when you were talking about the advance of technology, and I'm sure when somebody got an X-ray 60 years ago,
Yeah.
was a much different technology and dosing of that
much larger,
component than
much larger, much larger.
Right.
Yeah.
Right. So as you say, I think that the key to this is
education.
Is the education.
Education.
Because 2 and 2 does have to equal 4. So with some people, that's awfully difficult to do. So no, that's great. So that really is good to know. That I don't feel quite as I don't know, in a bad mood as when you first started with the problems regarding
But I
this.
don't want to think, it's an uphill battle. It is a big uphill battle, and it's going to take lots and lots of nuclear power plants. The good sign that I'm getting, what gives me hope are the developments that I'm seeing in India, in China, in South Korea, where they are also making these modular. Some of these modular designs are, again, the U.S. designs, but we just don't build them.
Mm-hmm.
We have to start coming around, building them, put them in the ships. And,
well, we have a whole nuclear field.
We have nuclear fleets.
Yes.
Yes, we do. That has not stopped, by the way.
Right. Yes, that they'll do.
We know. So we can, but we can. Those are small, relatively 200 megawatt, 100 megawatts kind of systems.
Exactly.
We can be using those, and those are factory built.
Yes.
Factory built and plopped on site instead of doing one off every time.
I want you to know I'm feeling better.
Okay.
I really want to thank you for being here today. You are always illuminating. You always have such wonderful things to say. And to our audience, I hope that you have learned as much as I have today, and it's always a pleasure to be with you. Until our next episode, I'm Jonathan Kleid. Thank you for joining us.